Explainer: How scientists know Earth is warming. With satellites and ice cores, scientists can calculate the planet's temperature by Sharon Oosthoek. Scientists have been saying for a long time that the Earth is getting warmer, but how do they know for sure? In this text from Science News for Kids, Sharon Oosthoek discusses how scientists measure the Earth's temperature. As you read, take notes on how human activity has contributed to the change in Earth's temperature. Temperatures on Earth can soar above 40 degrees Celsius or 104 degrees Fahrenheit and drop well below 0 degrees Celsius, 32 degrees Fahrenheit. Despite that variability, scientists can calculate a global average. Countries around the world have had reliable weather monitoring stations on land and sea since about 1880. In the 1960s, researchers also began taking the Earth's temperature with the help of satellites. Satellites don't measure temperature directly. Instead, they measure radiation given off by oxygen that's in Earth's atmosphere. The intensity of this radiation is linked to air temperatures. Computer programs take all of these data and turn them into a global average. Scientists use temperature readings from both satellites and climate monitoring stations to show that 2014 was officially the warmest year on record, at least through 2014. The temperatures have not stopped rising, however. By the close of 2015, temperatures were yet again about to hit a new record high. People have been keeping detailed temperature readings only as far as 1880, so scientists have to use other methods to calculate what earlier temperatures would have been. With these methods, they can now see that global temperatures have, at times in the distant past, been even higher than they are today. But the historical record also shows that over the past 100 years or so, temperatures have been rising exceptionally fast, notes Allegra Legrand. She is a climate scientist at the NASA Goddard Institute for Space Studies and the Center for Climate Systems Research in New York City. Isotopes are different forms of the same element that vary in their weight. Legrand finds clues about past and present climates in oxygen and hydrogen isotopes. Warmer temperatures and drier conditions in the atmosphere lead to the water in rain and snow having more heavy isotopes of both oxygen and hydrogen. Cooler, wetter conditions lead to greater numbers of the lighter isotopes of oxygen and hydrogen. Glaciers and ice sheets trap samples of oxygen and hydrogen isotopes from the Earth's atmosphere going back about 1 million years. As more snow piles up, the snow on the bottom gets compacted into ice. A new layer accumulates each year. Scientists drill and remove ice cores, long tubes of ice, from glaciers. Each layer of the ice core contains hydrogen and oxygen going back further in Earth's history. The amount of oxygen and hydrogen isotopes in each layer can tell us how warm or cold the climate was back then. Those ice cores show current warming is happening faster now than in the past. In the last million years or so, the planet has gone through a series of ice ages. The Earth got cooler, then warmed up. Research by the National Aeronautics and Space Administration shows that during the periods of warming, global temperatures rose 4 degrees Celsius to 7 degrees Celsius. That's 7.2 degrees Fahrenheit to 12.6 degrees Fahrenheit, over about 5,000 years. But in the past century, the temperature has climbed roughly 10 times faster. Temperatures are rising quickly now because of greenhouse gases, such as carbon dioxide and methane. When the planet's ground and water are warmed by the sun, they radiate heat back out into the atmosphere. Greenhouse gases trap that heat close to the planet's surface. That's good, up to a point. Life on Earth needs that warmth to survive. But pollution is adding additional greenhouse gases to the atmosphere. This happens every time people burn fossil fuels, such as coal, oil, or gas. During the Industrial Revolution, people started to burn large amounts of fossil fuels. We are burning even more today. Since about 1750, carbon dioxide levels have increased nearly 38%, at least through 2009, according to the data from the National Aeronautics and Space Administration. Methane concentrations have increased 148%, and levels of both greenhouse gases continue to rise. That has been trapping a lot of heat. As a result, Earth is warming.